So I'm going to make a little video for your review. This is over the quadratic equations day 2. We did this as a warm-up problem in class. So I want to go through quadratic, just kind of all the steps. So we have a stone being thrown from a cliff, and so what's going to happen is it's going to go up and then come back down. You can see it's an upside down parabola. So it says find the time taken for the stone to reach the maximum height. Now in Algebra 2 we would have done that as finding the vertex. So it's x equals negative b over 2a. And you can still do that. So negative 20 over 2 times negative 5, which is negative 20 over negative 10, which is at 2. And I said x, but t for this problem. So I know it's at 2, but I want to go ahead and make sure, just as a review on your calculator, that you know it works. And my batteries are low. I'm going to turn down the display a little bit. So I go to y equals and enter my two equations, or enter my equation. So negative 5 x squared plus 20x plus 60, and I graph it, and now I have a graph that's set from another problem. So I want to think about this problem first, and so I'm going to change the window. I'm going to go from negative 2. I know that I hit my maximum at 2, so I'm going to make it go to like 10, just to see what it looks like. And I know my y max, it starts at 60 and it goes up from there. So I'm just going to try 100. I don't know if that's going to work. And all I need to be able to do is see the whole parabola. So that window worked. If you didn't get that window, go back and pause it and watch that window. You don't have to have the same window. You just need to see the whole parabola. So if I calculate the maximum here, I can go on the left, or I can enter the number if I don't want to use the spider. I can go right and then enter. So that max is at 280. So I make this sketch at 280. So at 2 seconds is when it happens, and then the next question is what's the maximum height it reaches? It'd be 80 meters. So it starts at 60, goes up to 80, comes back down. Okay? How long does it take before the stone strikes the water? So we're trying to find when the height is 0. So you can look here, you could go to your table and see if it tells you, hopefully it hits nice. Yep, at 6 seconds the height is 0. And the way we found that was setting negative 5t squared plus 20t plus 60, setting that equal to 0. That's what you're doing when you graph and you look at the 0. Same thing. Okay? Make a sketch of the graph. Be sure to label axes and adjust window accordingly. So I already have a sketch up there. If I were going to use a graph paper, the things I want to make sure I have on there. If I'm sketching it just like it is here, the things I want to have my window and labeling that window. So my x max is 10, x min is negative 2. I know that I want to label this point. It's an important point. I'd want to put a 60 right here, maybe 100 up there. Obviously I didn't copy the same window, but you need to make sure that you label the scale somehow. Preferably you have more marks here along the way, but at least label your window of where it came from if you're copying that picture. Okay, and any critical points on there, you want to make sure that our place where we hit 60, I'd label that as well. And the domain and range of this problem, what do you think are the domain and range? Well, the domain is where we start, times 0 to 6. The problem stops after it hits the water, so the domain would be from 0 to 6. And then the range, smallest value is when he hits the water, highest value is the maximum height. So 0 to 80. All the values in between.